Hey, what's happening, guys? You are now being hypnotized. You want to buy multimeters. You need another multimeter. Just kidding. Actually, I want to read to you an email that I got last month. Yeah, last month from one of the companies I've dealt with a lot, which is, of course, Zotek, the DMM manufacturer. So they wrote to me and they said, "Hi, Paul. We are excited to introduce the ZT, that's Zebra Tango, 702S as in Sierra, a versatile handheld device that combines the functionalities of an oscilloscope and a multimeter. Are you interested?" Well, I, of course, applied in the affirmative. Yes, I'm interested. So, slide forward a couple of weeks, and this box arrived just yesterday. So you and me, we're going to sit here together, and we're going to open this up and check it out and see what's up. Now, you guys know as well as I do that for the last 2 weeks I've been sitting here by the door waiting for the truck to come, because this is a multimeter and an oscilloscope. Oh my God, what else could I ask for? Could you build one that has a spectrum analyzer built into it too? That'd be cool. Just saying. So the box is pretty nondescript. You know, sometimes it lists features. Not this time. All right, let's see what's in this nice nylon-ish carrying bag. Oh, I think I opened it the wrong way. I think it's probably supposed to go like this, maybe. All right, let's just get everything out. Nice little carrying bag. Okay. So it comes with a manual. Introduction. The handheld oscilloscope meter adopts double injection. Yeah, I don't care about any of how it's made. 2.8-inch IPS full color screen. Oh, 9,999 count. You know, when they said they were doing a multimeter oscilloscope together, I thought we were going to get a 2,000 count. So a 10,000 count's really nice. We have full color. Okay, when the voltages are made higher than 36 volts, or AC voltage higher than 25 volts, human body, okay, don't kill yourself, it says. Put the things in the right holes. Ground is ground. Okay. When using oscilloscope probe, the major voltage is higher than 25, 30. Ensure that the USB protective cover of the, okay, yeah. There's the USB. Okay. Very exciting. It's got soft buttons. It's got hard buttons. We got direction keys, which I'm guessing will work the same as our encoders on a standard. Yeah, coupling, trigger mode. Oh, look at that. Trigger mode. Auto, normal, single. That's nice. It has that. And you can select rising or falling. Probe attenuation. Auto off, 15 minutes, 30 minutes, 60 minutes, 120 minutes, or no. Backlight, 30%, 50%. Okay, this is really nice. More measures. Okay, so measurements. VMIN, RMS, period. There's got to be more measurements than that. Calibrate, reset, storage, enter. Okay, well, we'll figure it out as we go through it. Telling you how to compensate your probe. Auto setting, vertical, horizontal, trigger. Those are your three systems. Oscilloscope function. How to save measured wave? What? 1 second. So it will save your oscilloscope window in a flash memory. That's incredible. All right, let's have a look. So this would be in the range of what I would call the full-size multimeter. This is about the same size as your standard, you know, fluke meter, as opposed to like an 8. Let me demonstrate for you. One moment. I just happen to have a couple extra multimeters that we can use for this very purpose. Okay, so here's another one of what I call the full-size meter. That's the Kuwait's. You can see, yeah, the Kuwait's a little thicker, but they're basically the same size. And then this is what I call the handheld. So you get an idea there. So I would just call that, you know, your standard size multimeter. All right, so let's look at ports and whatnot inside of here. Get some light. Hang on. There, now we got some light. So we've got, you know, our square wave generator, 1 kilohertz, and we also have a USB-C port. On top, we have our oscilloscope input. I'm having a thought, which is why I'm not speaking. I think this has rechargeable batteries. Did it say that in the manual? Probe. Hang on here. Measuring. Let's go to technical specifications on page 24. F54. All right, yeah, here we go. Charging batteries. When the power symbol appears in the upper right corner, it should be charged in the following steps. Plug it into a Type-C until it's done. If the instrument is not used for a long time, it should be charged to 50% electricity, taken out and stored in a cool, dry environment, lithium battery. Oh, it uses 18650s. Awesome. It is about time that somebody use 18650s in a multimeter. That's great. Here are some technical, mechanical, and electrical specifications for your edification. You know, you can just pause this video while you're having a seat on the old throne, you know, after your cup of coffee, and check them out. However it makes you happy. I am simply providing the information. Okay, oscilloscope specifications, 10 megahertz. That's very low. But 48 megasamples a second. Yikes. Channels 1, well, that's what you expect. Input coupling, AC-DC, resistance 1 megohm, 16 picofarads, about standard. Sample rate range from the horizontal, 1.5 seconds. No, 1.5 samples per second, sample rate. 1.5 samples per second to 48 megasamples? Okay. That's strange. Sin x-axis for interpolation, sweep speed. We can go from 100 nanoseconds per division to 20 seconds per division. Check this out. Somebody had to correct that one in the mail. You can tell I got a prototype here. That's cool. 100 nanoseconds per division. All right, time-based accuracy, 20 parts per million, record length, displacement range, 4 cells, 10 megahertz, 10 nanosecond. Rise time's a little slow. Automatic measurement, period, frequency, peak to peak. We're going to check all this out. Don't you worry yourself, not one little bit. We just want to get the specifications out of the way, because if I don't, somebody will complain that I didn't, you know? All right, we ready to have a look at this guy? Stop testing voltage and current mode. Okay. I won't test voltage and current mode anymore. All right, let's turn it on and get a look here. Get a look, see? That's a nice screen. I'm just taking it all in. R range, hold save function. Voltage time. Move. Okay, voltage time. Okay, so I'm adjusting the vertical there and the horizontal there. I see. Okay, menu. Oh wow, trigger, probe. Trigger's rising. Trigger mode auto, coupling is DC. DC, yeah, DC. No, DC. Trigger, move. Mode. Oh, that's my multimeter mode. How cool is that? Okay, that's the coolest looking multimeter screen I think I've ever seen. Wowzers. Well, let's hook a probe up to this. What do you say? Luckily, I say luckily, boy, I keep my feathers numbered for just such an occasion. Also, luckily, they sent along a probe. Not really luckily, I think I have a number of probes hanging there. But always nice to get a probe. These are the ones you're going to get with basically all of your low to intermediate end of the Asian market oscilloscopes. I think they're called like P200s or something along that line. Yeah. So this connects to the top of our scope just like any other oscilloscope. We'll get this door open so we can get into the side port there. Here we go. Power up. And we'll clip on our ground and our probe. We'll hit auto range and we'll see what it does. Perfect is what it does. Okay, so now I should be able to adjust vertically this way. Okay, I'm pressing the down button and they're getting bigger. The up button makes them smaller. That's backwards in my brain. What about in yours? All right, so we got frequency, 1K, peak to peak voltage of 3 volts, and a Vmax of 1.48. Now, how did it get to that other more measurements? Dang, I'm gonna have to look in the manual. Okay. So menu, and then I didn't notice there's a little white arrow there at the edge. So we can go over here. We can turn on more measurements, and now we have our Vmin, our RMS, and our period. We have our backlight control, our auto off, our language English. We can calibrate it, reset it, storage. Oh, this is awesome. Awesome, awesome, awesome. Well, let's calibrate it. I am not inputting a signal. Okay, I guess. They usually tell you to remove that first. It didn't, but okay. I'm not exactly sure what it's doing. It seems to be dropping down. Maybe it's going through, yeah, each of these ranges. Yeah, now it's at 200 millivolts. $500, and I heard a relay click. So we'll just wait and let this thing finish calibrating. Hopefully it should be just about done here. Yes, calibrate. Success. All right, let me get a BNC cable here, and we'll hook it up to the function generator. One moment, please. Okay, I got the function generator set up, as you can see, for 1,000 hertz, 1 kilohertz, square wave, 5 volts, peak to peak, no offset, 50% duty cycle. So let me bring this out here. I don't have much cable here, so I have to get kind of close. And we'll power this guy up. And we'll hit the auto range. $1K. Peak to peak is 5.23. Okay. It's a little high. I mean, it's a 0.15 volt high. I mean, it's not that big of a deal, but when we're dealing with digital stuff, honestly, I expect better. All right, let's change this to triangle wave. Looks good, and I should be able to adjust my vertical just like that. You always want to take up the most screen as possible. That gives you the best reading. Ramp. That's CMOS, EC. Okay, let's go back to a sine wave here. And now what we're going to do is we are going to change the frequency. We're going to start going higher as soon as I find the frequency button. Oh, here it is. No? 1 second. I lost my mind here. Okay, now we're looking at a 10K sine wave. Oops. I'm just looking at the measurements, frequency, peak to peak. All right. Go to 100,000. $100,000's right on. Peak to peak is closer. 1 megahertz. Yeah, I mean, there's for a 10 kilohertz scope, or is it 10 megahertz? 20 megahertz? Now I gotta look it up because I don't remember. I thought it was like stupid slow. Hang on here. One moment. Found it. 10 megahertz. All right, let's go to 10. Yeah, now we've lost it. You see, we're not getting a stable signal. Let me move in closer so maybe you guys can get a better look on this without so much glare. Hang on. There we go. All right, 10 megahertz. Let's change the waveform. Square wave does not recognize it. Triangle. Yeah. No changes at all. But that's okay. It is within the spec that they're advertising. I was just seeing how far it would go. I have no complaints at all. I mean, this is fantastic. I don't know what their list price on this is going to be. Let me see if I can find it out there anywhere. Give me 1 second. I'll shut this off. Well, it's that time you've all been waiting for. It's taking apart time. I'm using this little RMO65 adjustment screwdriver, but it fits in there perfectly. It did not take an incredible amount of force to break the screws loose. As you can see, I'm getting them to crack with just mostly finger pressure, not even using a lot of wrist. Getting in there pretty good. All right, I'm going to get these screws out and I'll be back. All right, let's see where we're at. These ones don't feel like they're out yet. That one's all the way out. How about this one? This one's still... Oh yeah, that one's still way in there. Okay. Let's get in there and get a close-up on this. What do you say? All right, here we are. Down at the bottom end. We'll start here. We have our multimeter inputs. There's our current shunt. And there's one of our fuses. There's the other one. I can't read what they say, but that's okay. They're specified in the manual. We have some MELF resistors. 1, 2, 3. We have a diode here. We have our relay here, which you heard switching earlier. We got an IC here with a clock, 4 megahertz, so this is probably a microprocessor. Yeah, it's definitely a microprocessor because I can see Atmel inscribed on it, barely. Here we got a little 8-pin chip. I can't quite tell what it says. Another 8-pin here. These are probably op amps. This one, and this one. Diode. Diode. Here is our front end in from the oscilloscope BNC jack. Little 5-pin over here, probably a voltage regulator. There's a connection from the other side. Now this I can't find anywhere. The closest thing that I can find says it is an international rectifier Hi-Rel. Damn it, let's see if I can find any more information on it. Some sort of DC-DC microcircuit hybrid converter. I'm not familiar with that IC, but then there are millions in the world. So, you know, a lot of people are going to be familiar with a lot of things. Here is damn if that don't look like an I squared C. Voltage, ground, data, S clock. I squared C, really? I will check with Zoyi and or Zotek, Zoyi, same company, like GMC Chevy. They've done some really heavy-duty soldering here for the battery contacts. And as you can see here, they've laid some really wide copper, put vias in it to let some of the heat out. You can see that track down through here and through here. So this must be our larger fuse for the 10 amp fuse, and then this will be the smaller one. That makes good sense. There is our buzzer. So we come over here. Oh, it just fell right out. We have our USB jack, and then this is the output from that square wave generator, which could be done with, you know, one of the op amps that are on this board. It's pretty easy to make an op amp oscillator. Yeah. Shall we have a look at the battery? Don't stick metal things in your battery, Paul. Lever that guy up out of there. This is a Yanai lithium ion 18650, 74 watt hour, 200 milliamp hour, and it does have nipples. All right, I'm gonna put this back together, and one thing you can see here, let me zoom out. The screws are captured. Very nice. Everything about this is very nice. You know, I've been a fan of Zotek for a long time. Back when the Anang 8008 first came out, was my first experience with them. And yeah, that's the same company. So I've gone through a lot of their meters, and they're all basically just journeyman-like. That's what I'll say. They're good. They ain't flukes, but they ain't B-side either. They're good. They're good. They're solid. And as I showed you here, this one has decent protection. You know, if you're a professional that needs... Dogly is here. If you are a professional that needs an oscilloscope in addition to the multimeter in the field, that's not a bad option, right? Hi, Doglies. What do a dog want? What you need, baby love girl? Huh? Oh, you coming up close. Hello. You got a kiss for me? Thank you. Okay. So, make sure it still works. Yeah. I don't like to make videos too long. So we're going to cut this one here. And we'll come back the next time and look at the multimeter side of things. But there's some other stuff I want to look at in here too. And I don't want to rush it because this is so cool. But let me tell you one last thing before I leave. What would you pay for something like this? Multimeter, oscilloscope, temperature probe, you know. Everything a growing boy could want. I mean, that's basically like a electronics lab. You can fit in a jacket pocket. Well, they're selling for about 60 bucks. Holy cow. This would have been amazing to have back when I was in the Navy in the late 80s, early 90s. In 93, we got I think it was a Fluke handheld, called like a scope meter. And it was still, you know, much larger than this, but at least it was portable. All right, guys, I would like to thank Zotek Zoyi for sending this out to us free of charge for our consideration. But I want to thank you right there most of all for watching this. I wouldn't be here if it wasn't for you. You guys give me a reason to keep making these videos. I'll keep making them. All right, that's it. I'm out. Peace.